So as Chris said, my name is Yeff, and I'm a mechanical engineer, and I will talk to you about what engineers do, what I do in my role as a mechanical engineer, and I will give you a glimpse of the day-to-day life of an engineer at work. So to start is the first question: what do engineers do, and what do they work with? To simply answer this question, it's everything. Everything you can see around you, everything you come across on the way to school, like cars, your chairs, computers, buildings, all the way to the space rockets. At some point, engineers were involved in the design or the build of all these objects. So depending on the discipline, you will be working with different things. And what I'd like to do today is to tell you about the things I was involved in, and as a mechanical engineer, I will try to explain how they work, bring some analogies from your day-to-day life. So hopefully it will make sense. I started my career in automotive industry, working with cars, and I was developing the power steering for the cars, the electric power steering, the thing which makes the car turn easily. So let's look at how it works, and for that I'd show you a horse. So how does the horse rider make the horse turn? Typically he's gonna pull on the rein, and that's gonna send a signal to the horse's brain. The signal is going to be processed, and then the horse is going to send the signal to the legs to turn. And this is very similar to how the power steering works in the car. When the driver applies the force on the steering wheel, the signal is sent into the electronic control unit, which acts as the brain for the steering system. It processes the signal, sends it to the motor, which applies the force to the wheels. So quite a similar setup. You have a force applied, which is processed in the brain, and then you have the action. So the two main design considerations here are the programming the control unit, i.e. brain of the steering, and getting the mechanics right. So the forces can be transferred to the wheels without breakages. If you can work these two things out, you have the power steering in your pocket. So I spent about 2 years working with cars, and then I moved into the industrial gas industry, working mainly with various gases like air, oxygen, nitrogen. So it's completely different from the automotive industry. And my first gas project was flow meter, development of the flow meter. So this is a black box which sits on the pipe and shows you a number. You can you have flow meters at home, like your water meter or the gas meter, which shows you how much gas you're using for your heating, for example. So there are various ways of various types of the flow meters. The one I worked on was based on the differential pressure measurement. And to explain how that works, I will use a little man. You can see a little man there running in the pipe, and to make it work, you place the restriction in the pipe, and as little men approach the restriction, they will start climbing over it and speed up to give the way to others. And if you can count little men before the restriction and after the restriction, and this is what these two bigger men are doing on top of the pipe, you can calculate the flow. Again, like two main considerations here is sizing the restriction, so the little man can efficiently climb over it, and finding this bigger man who can count the little man in the pipe. And again, if you sort these two things out, you can design a flow meter. So that was my first project in the gas world. My second gas project was design of the pressure vessels. And the pressure vessels are used for gas storage. You can see one in the picture here is a 15-meter tall pressure vessel, which I worked on. You can see this little yellow man next to it. You can think of the pressure vessel as air balloon. It kind of does the same function. You pump the air inside of it, and you store it in there. And again, things to consider here are the size of the vessel. Is it adequate for the amount of gas you want to store? Same with the balloons. You have a smaller balloons, you have a bigger balloons, you have a long balloons. And also the material you make the vessel of and the wall thickness. Because if you get these things wrong, the vessel is going to explode, and you don't want that to happen. And in my current role, I am working as the equipment condition monitoring engineer. And the analogy I came up with for that is your smartwatches and fitness trackers. You have a fitness tracker which tracks your activity and looks at your heart rate, and you can review the data remotely. So I'm doing something similar with the instruments installed on the equipment on our plants all across Europe, which act as the fitness trackers. And all the data from this equipment fitness trackers are coming to my computer in the office, and I can review the data and see the activity of the machines and review their heart rate to make sure they are running okay and there are no issues. And if there are some issues identified, then we can plan the maintenance on them or see if we can run the machines differently. So this is my current role. And as I said in the beginning, the engineers are working on pretty much everything you can think of, depending on their discipline. And I'm, as a mechanical engineer, in my short career, I already worked with cars, flow meters, pressure vessels, and fitness trackers for the equipment. So it's quite a varied job. And now I'd like to give you a glimpse of a day-to-day life of an engineer, what we're up to during the days. And again, this varies quite a lot depending on your role, and every role is different. It can go from full-time office-based or full-time based in a lab to full-time on the road and traveling everywhere. My job is mainly office-based. As I mentioned before, it's looking at the data from all these equipment fitness trackers. So I spend most of the time in the office, but occasionally I do travel across Europe, going to sites to get some more data from the machines. This is me taking the vibration readings from one of the compressors in Daytoday. And then every so often you're running some interesting projects. Like this is from my days in the pressure vessels or air balloons, where we were lowering this 15-meter tall vessel inside of the building. So that was quite an interesting project. And with regards to travel, as I said, depending on your role, you can travel a lot. My role predominantly office-based, but I've been traveling quite a bit, going to different offices or different labs. So currently I'm based in Horsham and Surrey, and I've been based full-time in Solihull and Basingstoke. So these are my 3 offices which I spend most of my time in my career. And with work, I traveled pretty much everywhere in England. I also was traveling to Europe. I visited countries like Poland, Germany, Netherlands. And work also took me to America and China. So again, as I said before, depending on your role, you can travel more, you can travel less. And to sum it all up, here's an old school engineer with his drawing board and pencil. Most of the to be a good engineer, you need to be a good problem solver, and you have to have a desire to figure things out. Think outside of the box and be open-minded, so you can solve all these problems. You also need creativity, because you need to be able to come up with the new things, the things people haven't thought of before, or the things which are currently not working. You need to try and solve and find the solutions how to fix them. You're also quite key to the engineer is the communication skills and being a good team player, because problem solving comes better when you talk about it and you work in the teams. But that is all I have for you today, and I will happily answer your questions today. Hopefully it wasn't too much and it made sense and you can design a flow meter now.
Excellent, thanks, Yeff. Can you do me a favor? Can you come out of the presentation so your face is full screen?
What can you see now?
Yeah, and you haven't gone full screen. That's strange. It's very strange. I don't know what's happening there. Okay, so oh, there we go. There we are. Okay, so have any questions coming through? Oh, look, there's loads of them.
Right, I need to find the questions first. Give me a second.
Right, so...
Oh, here we go. I see the chat now. Right, let me go all the way up.
Ooh, you're coming in thick and fast.
How can you practice skills to be an engineer as a kid? I think it's mainly trying to understand how the things work and looking at all the objects you come across and the things you come across is trying to understand how it's all put together, how it works, why is it done in this particular way. And if you constantly think about it, you will start noticing the similarities between completely different objects. You will start noticing similarities, which kind of shows you so this is the same idea applied differently. And once you have this knowledge of these different ideas, which you can apply to different things to solve the problems, that's how you become a great engineer. So yeah, as a kid, just think about how things are made and why they're made this way. What's the best bit about being an engineer? Coming up with a solution. I think for me, if you're looking and trying to solve something for a few days or weeks, and in the end, when you put it all together and it finally works, or you can see the final product, that is quite an interesting feeling, which is difficult to describe. So once you see your work in real life and it's doing something, that's a very good feeling. How do you get the vibration readings? There are few various instruments you can use. The most commonly used in ours is the proximity probes. That's basically a probe which emits some electrical signal. It looks at the shaft, and depending on how close it is to the shaft, it will send you the different voltage. And as the shaft vibrates and moves closer and further away from the probe, you can read that voltage, and that will give you your vibration reading. But there are tons of different ways of measuring it. So this is the most common one used, which I'm looking at. So hopefully that answers that question. Do you ever work hands-on with equipment? Yes, this again depends on the role you're in. Like in the flow meter, like when I was designing the flow meter, most of my time I was actually in the lab, putting it all together and testing it. And this was kind of a brand new design of the flow meter. It wasn't done before, so we were literally putting it together in the lab from bits and pieces. So yes, depends on your role. You can be doing more or less of that. For me, I like to strike a good balance between working in the office and working hands-on with the equipment. Do you need computing skills? Again, depends on the role. If it's something because now like Internet of Things is getting a big thing, and your software development and your application development is quite a big thing now. So for that, you'll definitely need the computing skills. For other roles like the pressure vessels engineer or even designing the flow meter, As long as you are okay with your standard office suit, then you should be okay. There is no need for hardcore coding skills. So again, it depends on the role, but no, you don't need them in all the roles. What is the biggest problem you've had to face? What is the biggest problem you had to face? That's a difficult one. They always catch me out. Well, the interesting problem I had to face is the vessel I showed you before, that 15-meter tall vessel, which we had to lower into the building. And the problem was it had to be installed on the other side of the building. So we had to move it across the floor, and it is, I think it was 25 tons. So it's quite heavy vessel and quite tall vessel as well. So we had to lower it into the building, and we had to move it across the floor. And we couldn't use the overhead crane because the building was like 15.5 meters tall and the vessel was 15 meters tall. And I did a bit of research and then looked at the abnormal load engineering companies and came up with this solution of using the roller skates, where you put the vessel onto the roller skate, you slide it across to the position it should be in, and you take the skates out. So that was quite an interesting problem, and with quite a neat solution, which worked out well. The vessel was installed, so that worked out well. So I'm quite happy. What is the biggest problem you've had to face? Just answer that. And next one is, what if the gas thing pops? The gas thing, I assume it's the vessel. It depends on what pressure is inside. Nothing good comes out of it usually, but you typically have a pressure relief valves, which are designed, if you have the overpressure situation, they are designed to let go of first. So you have a point in the vessel which will fail first, and that way you can fail it under control. So it doesn't fail catastrophically. You will just have this, like the relief valve opening or the bursting disc failing. So there's going to be probably quite a bit of noise, but it shouldn't fail catastrophically. So there are protection in place of the things like the overpressure of the vessel. But if you get those things wrong, then it is nothing good is going to come out of it. The vessel can shoot as a rocket. Hopefully that answers this question as well. Why did you want to become an engineer? I think it's just that curiosity about things, and then as I said to the question about how to develop the engineering skills as a kid, I always was interested in how the things are put together. I was taking them apart and trying to understand why they are put together in this way. And I think that's the curiosity towards the understanding of how things work. That's what led me to become an engineer. And that answers the next question, which is, why did you become an engineer? I think because I was interested in making things and understanding things. Have you noticed a shift in engineering since you started? Yes and no. In some disciplines, they are quite, like, again, I'll use the pressure vessels as an example. This is quite a established discipline. There isn't much development in there. That's kind of like at its peak now, so it doesn't change a lot and rapidly. But like things like the fitness trackers on the equipment, that is quite new. It's about like 5-10-year-old system, and that's developing quite quickly, and more companies are looking into it now. So more and more time is spent on it. There is definitely a step change in the monitoring of the equipment and monitoring of your processes. How much money do you earn being an engineer? It's a good salary. It is enough. It's more than some, less than some, but it's a good salary. Like typically we're talking about after university, after the graduation from university, depending on the location, but you're talking about like from 20 to 40,000 a year starting salary for an engineer. Where are you from originally? I have a Russian background. I was born in Soviet Union, and then I lived in Latvia. I did my degree in Sheffield, Yorkshire. Then I worked in Midlands for a little bit, and now I'm in Surrey. So I keep moving. But originally, yeah, I have Russian background. Do you enjoy your job? Yes, I do. But again, depending on the project, some projects are boring, some projects are exciting. And then you always have your day-to-day routine job as well. But every so often you have an exciting problem, you have an exciting project which keeps me running. So yes, I do enjoy my job. What inspired you to be an engineer? As I said, just the curiosity and the willingness to understand how things work. What kind of a degree do you need for an engineer? The university degree in engineering, and there are various disciplines. There are loads and loads and loads of disciplines of engineering. From like the mechanical engineering is my degree. I have a degree in mechanical engineering. Then you have aerospace engineering, structural engineering, process safety engineering, sports engineering. There are lots of degrees, and typically you can apply the various engineering degrees to like a job like what I'm doing as a condition monitoring. If you have a degree in sports engineering, you're very likely to be able to get this job. So a degree in engineering in any discipline would may land you a job in engineering if you want to. How many hours do you work in a week? I am working the 37.5 working week, so that's kind of like 9 to 5 job with a lunch break, Monday to Friday, and then the weekends are weekends. But sometimes you have, again, depending on the project or if there is a shutdown, sometimes you have to do the weekends. But mainly it's Monday to Friday, 9 to 5. Which subject did you most enjoy at school? Did you learn engineering there? No, I didn't learn engineering at school, but the subjects I enjoyed and which are quite helpful to become an engineer are maths, because you end up working with the numbers, and physics, chemistry if you want to be a chemical engineer. So these are quite an important subjects. For me, it was like physics and maths were my two favorite subjects in there. When did your career begin? So I started in automotive company as part of my degree, and that was in 2011, so about 7 years ago. 7 years ago was my first job as an engineer. What would the average salary of an engineer be? Depending on your job and on your experience, but as I said, hello, I've been muted there for a second. Hopefully you can hear me now.
Sorry, that was me.
Okay. Okay, so I was on the salary question. As I said, the starting salary, depending on your location in the UK, is between 20 and 40,000, and then it goes up with your experience. Have you ever worked on airplanes? No, I haven't. But the things I'd like to work on are either space rockets or submarines. I don't know, for some reason they interest me, but I haven't worked on airplanes yet. Do you enjoy your job? Yes, I have answered that before. I do enjoy my job, and as I said, these are these interesting projects which come along every so often, which keeps me running. Who inspired you to be an engineer? I don't think I had a figure who inspired me, but as I said, it's my curiosity to understanding the world and how things work. That's what drove me to become an engineer. How long does it take to complete a project? That depends entirely on the project. You can have shorter projects which will last a few weeks or a couple of months, and you can have projects which are going for years. So for example, from from my experience, that flow meter project was running for 3 years. That big vessel project, we've done it in, I think, just under 12 months. So it depends on the project, on the scale of project and what you're doing. What is the hardest thing you've had to do in your career? What was the hardest thing I had to do in my career? It's probably finding a job. I think the hardest thing I had to do is to decide where you actually want to work. Because as I said, being an engineer, you can work with everything, and it's making that decision where you want to concentrate your efforts on and where you want to spend the next few years. That is a difficult one. So hopefully that answers this question. What is your favorite thing about being an engineer? That is solving the problems and seeing your product in life after your project is complete, like seeing that vessel being installed in the building after I worked on it for 12 months. That was quite a good feeling. So yeah, that's my favorite part is once you solve the problem and it works. What qualifications do you need to be an engineer? I touched on it before. It's a degree in engineering from university is the standard one, but you can also do the apprenticeships and do a part-time course in college. And then, as an apprentice with experience, you can become an engineer after finish your college courses. But the standard one is 3 or 4 years at university doing the engineering degree. Why did you choose this type of engineering? I went down the route of mechanical engineering because that's kind of includes, it's the most versatile one. It includes the mechanics of fluids like your liquids and gases, and it also includes the mechanics of materials like your steel and structures. So it's kind of a little bit of everything, and again that gives the flexibility of deciding where to go after the degree. So yeah, that's why I picked mechanical engineering, because of the variety of subjects you cover in as part of the mechanical engineering degree. What is it like being an engineer? Question from Benjamin. That's a difficult one. You've seen my day-to-day activities, so that's pretty much how it's like being an engineer. But it's good at times when you see the things and then you kind of like, no, why it made this way. And sometimes it's not helpful when you're kind of like boarding the plane and you see a crack somewhere and you think, oh, that's not good. Yeah, as an engineer, when you design things, you know what there is a probability of it failing. So whatever you do, you know it can fail. So that's the bad part about being an engineer. How long have you been an engineer for? So as I said, my start was in 2011, 7 years ago, and then I finished my degree. So in my current company, I was working for just over 5 years. So 5-6 years. Why is it important to be flexible as an engineer? I think it's one of the things is it's always moving target. As the projects can run for a few years, the things can change, and there may be like new materials available which you may consider in your design, which you haven't thought about in the beginning, and it's quite difficult for a lot of people to drop something they were working on for 6 months or so and look at something else. But if you don't do that, you can miss this opportunity of the new materials available or new information available. So yeah, because the projects are running, most of the projects are running for quite a long time, there can be new information, new materials, new budgets available. So you need to be able to adjust quickly to the new conditions and the new scope. So you stay competitive. Do you get annoyed when things don't work or fix first time? Yes, I guess depends on how much confidence you had in the fact that it's going to work. If it doesn't work first time, then very rarely, because it's not often that a thing's going to work first time. But if you try it tens and tens of iterations, and this time you show it's going to work because you found the problem, and it doesn't work, then that's when it's getting annoyed, because you found the wrong problem and you were solving a wrong problem. But from the first time, typically not, because you typically don't expect them to work from the first time. Who or what inspired you to be an engineer? That I've answered before. How many years did it take for you to become an engineer? So as I said, I was curious most of my life, trying to understand how things are put together. But formally, I had a master's degree in engineering, which with industrial placement, which is a 5-year-long course. So you do 3 years, 3 years in university, with the 3rd year being a design project. Then you spend the 4th year in the industry, and this is when I was working in automotive industry. And then you come back for your final year to university, which is the 5th year. So 5 years at university, and I'm an engineer. What first interested you about engineering? That's my curiosity, I think. And when I heard what basically you have these engineers who know stuff, that's probably what triggered me to be interested in engineering. How long did it take you to become an engineer? I think I just answered that. How many things have you designed? Not many. So I was working a part of the team for the development of the power steering. So we were working on the ball bearing. So there's one. I'm just counting my years now. So the 2 vessels on the vessel year, so another 2, and bits and pieces of the flow meter. So 4 things in 7 years. What did you study at school? I just had a general education, so I had everything from literature, biology, history, to the maths, physics, and chemistry. So everything, and I also had a Russian literature, Russian language. But yeah, so everything. How old were you when you started to train to be an engineer? 19, I think it was 19 when I went to university, and before that, there was just like a school level maths and physics. So 19. What is the best thing you've ever made as an engineer? Oh, that's a difficult one. I don't think I can answer it from the top of my head. What is the best thing you ever made as an engineer? No, don't have the answer. I think just like every little thing you do to improve the product, which makes the people's lives easier, that's kind of adds up to one big thing, which is quite good. So like improving design of the power steering is when it's easier for manufacturers to make it, so they don't spend much energy on the manufacturing, or it's easier for end user to use it. Every little improvement on a big scale, it's adds up. If you weren't an engineer, what other career would you like to do? Before I kind of decided on engineering, there were 2 options of either doing a law or being a cook. So I scrapped the cook idea quite quickly, and then ended up applying to the engineering courses. So I guess I'd be a lawyer. What's the hardest thing about your job? There are few difficult difficult bit is depending on the project. If you can't work it out and you can't find a solution, that's maybe quite difficult. But also, if you have a great solution and great project, it may be difficult to sell it to the to people, to like your idea what it's going to work, and to get the people on board with it. So that could be difficult as well. So that depends. Do you like your job? Yes, I've touched on it before. Next one is, what inspired you to be an engineer? We had it before as well. I'm gonna skip that. The next one, how many designs would you go through before the final one? How often do things not work out? That's a good question. Typically, when you design a new product, you have a different stages. And in the first stage, you go through various concepts, and you, this is where pretty much you agree on which design you're going to take forward. And then after that, as you develop it, you have another gateways where you stop, you review if it's working or not, and then you make a decision with all the stakeholders. You make a decision if you're going to carry on with this design, or it's not working out, we can't achieve the goals, and we got to scrap it. And then at that point, if you decide not to move forward with this design, you will either go back to your original, the first stage of selecting the design, or you may go completely to a new product. So how many designs is difficult to say, but as I said, you have this continuous review of your design, and you decide if you're gonna keep spending time and money on trying to make it work, or you're just gonna shelve it and move on. What languages do you speak, and is this skill useful? My first language is Russian, then I speak English, and I know Latvian as well. In my day-to-day job now, I don't really use Russian, but it is definitely useful. And there are a lot of jobs, because we have projects and plants and offices all over Europe. So any additional language is quite useful. But it depends on your company, where you are, and where they're doing business. So yeah. What are you working on at the moment? At the moment, I'm still collecting all my so-called fitness trackers from the equipment. So I have all the data I can in my tool, and then once we have all the data linked up to my condition monitoring tool, then I know what most of our machines are protected. What project are you most proud of? I'll go back to my pressure vessel, and I think it's because I've seen that project from the beginning to the end, and it went from just the process specification on how much gas they at what pressure they want to store, to vessel being installed and used. Because quite often, not quite often, but like in the beginning of your career, you go from project to project, or from assignment to assignment, and you can join the project halfway through, and then you can leave before it's finished. And as I said, like once you see that product in the end, which you were working on, being built and it's working, that's a good feeling. And I think that's why I've seen that vessel from the piece of paper to being installed inside of this building. That kind of stayed with me. What do you earn as an engineer? I've answered that before. That starting salary after graduation in the UK is typically between 20 and 40,000 pounds a year, depending on your location and the industry. Have you used your engineering skills to solve a problem at home? Yes, I think just like being an engineer, you typically have a good common sense, and whatever we're dealing with, we just apply our knowledge on all the problems. Like Like one example which just springs to my mind is giving a name to a daughter. And we had a little specification on kind of how big it should be, how should it sound, it should work in different languages. So going from that specification, we picked a name for our daughter. So yes, we have solved problems at home, and we recently moved as well. And it's just doing the works at home. Being an engineer is helpful. Why did you want to be an engineer? I've touched on that, so I'm going to skip it. How do you make a blueprint? I'm not really sure what this question means, so I'm going to skip it. If you can type the follow-up question to that, I'll happily answer it. But what is your favorite achievement as an engineer? I've talked about that air balloon. Why do you like engineering? That is again, it's my curiosity to problem solving and understanding how things work. What made you want to become an engineer? I talked about that. I'm going to skip it. How many people work at your company? In the company worldwide, we have just under 20,000 employees, so it's quite a big company. In our office here in Surrey, I think it's about a couple of hundred people based here. In my team, where I work now, we are 8 or 9 people. So it's kind of like it's growing up. So eight, 9 people in our team, a couple of hundred people in the office, and then just under 20,000 people worldwide. What's the easier part of your job? I guess it's your day-to-day routine activities are easy to do. You know what you're doing. You know what you're looking for. You just do them automatically. They're not most fun. It's not my most fun part of my job, but it's the easy part of my job. What kind of problems do you solve? So one example is we had to move that vessel across the floor inside of the building, and it's 25-ton vessel. It's like, how do you do it? You can't. And then once you start looking and solving these problems, you kind of like, okay, we'll use the crane. And it's just like, oh no, we can't use the crane. So the next solution. So you need to have several solutions and see if you can apply them or not. So that's one example. Another one, being the flow meter, where I showed you this little man climbing over the orifice, the restriction. So it's trying different size restrictions, trying different bigger men who are counting the man, and then finding the optimal solution for your application, like for your gas and the flows. What will give you the optimum solution? And in my current role, the problems I look at are with getting all this data. It is a lot of data from all this equipment from Europe, which is a real problem, or which is just a data blip. So that's kind of the main activity I'm involved with now is recognizing the real problems from all this data. What qualifications do we need to get into engineering? Is it difficult to get into? As I said again, the easiest way is engineering degree. I don't think it's the easiest of the degrees, but if you're good with numbers and common sense, then it's achievable. And is it difficult to get into? No, once you have a degree, then there are plenty of jobs available around, in the UK at least now. Who inspired you to be an engineer? I've answered that. Do you enjoy being an engineer? Yes, I do. I did expand on that before as well, so I'm going to skip it. Sorry. Who inspired you? Yep, we talked about that. What company do you work for? I work now for the industrial gas company called Air Products. So they're making gases like oxygen, nitrogen for various industries, like for the food manufacturers, in your packaging, like your salads or crisps, they have the nitrogen in the bags, so they stay dry and crispy. Or you have the oxygen for the furnaces to melt the glass and steel. You also have the welding gases. So these are the guys I work for now. How many hours do you work each week? 37.5. I did expand on that before as well. What is the main thing you do as an engineer? It depends on your role. As I said, in my current role, I mainly look at all this data from the compressors and decide which data we need to action on, which compressor needs some work doing, or which one is just a blip in data, or maybe we need to add more instruments. So our data from these instruments and fitness trackers are better, so we can make solutions on that. So that's kind of my day-to-day job now. What was the longest project you have ever worked on? That's probably the one I haven't seen the end of. I'd say, well, the flow meter was the long one. I worked on it for a year only, and the project lasted 3 or 4 years. I won't be surprised if it's still running now. So that's quite a long one. What tools do you use? Now, pretty much laptop, and then we have some diagnostic equipment to take the readings from the instruments on the compressors. But yeah, you use a lot of softwares on your computer, and the for like vessels, we had a software which were calculating the stresses in the vessels. You have the software which calculates the flows and pressures. So yeah, the laptop is my main tool at the moment. Do you have any tips for young people interested in engineering? Yes, be curious. Try to work things out and understand why the things are the way they are. Also be observant. Observe things around you, like in nature, because there are a lot of things which are copied from the nature into the designs. So yeah, be curious. Put things together, bang them. It's like how the little ones work out the way in life. They just take two pieces, bang them together, and see what it makes. So yeah, that's my advice. How many hours do you work a week? 37.5. Do any female engineers work within your department? Yes, we have quite a few female engineers. They're not as many as the male engineers at the moment, but there are more and more female engineers coming out from the universities. So yes, and there are lots of activities in trying to interest female to join the engineering. So that is, don't make it stop you. Definitely think about engineering as your degree. What age did you start your job? So I graduated in 2013, so 23, 24-year-old I was when I joined the company on a full-time basis after my university. 23, 24 years old, I think. How heavy was the big gas tank you made? That was 25 tons. So that's quite heavy. So the car weighs just over a ton, so 20 cars. That's the mass of the tank. How does a zip work? That is an interesting and random question. If you look at it, you should be able to work it out. So one end is narrow, the other one is wide, and on the wide end you have a separator which is at the top. So when you pull it up, the narrow bit pushes the teeth of each side together, and they just hold. But then when you pull it down to open it up, the wide end with the separator just pulls them apart. So if you look at it while you do and undo your zip, that should be a better answer than what I was trying to explain now. But hopefully it makes sense. The engineering salaries I touched on before. What was the most difficult thing to create? The flow meter, because I haven't finished it. I left that project. But that was on the other side. That was kind of making it with the new technology from scratch. So that's why it was more difficult, because you basically were doing the test and trying to work it out yourself. It's not like you could go to someone for the advice and ask all the questions and get all the answers. There were a lot of tests to be done and understanding on how this new technology works. How long do you work? It's a 37.5-hour week. Did you always want to be an engineer? I'm not sure. I kind of touched on it about considering career in law and being a chef. So I guess it's a no for that question. But once I decided I want to be an engineer, I haven't really looked back. I just realized what this was the right choice. What is the longest project you have worked on? I have answered that. That was a 3 or 4-year-old long project of the flow meter, which I haven't completed, and I moved to a different role. What age do you need to start engineering? There are a lot of STEM activities which companies are organizing, so you can start working things out and putting them together by attending these STEM activities. And they like what are you doing now? You're joining for this presentation, so that's a good age to start. Think about it and then think what else you need to look at. So as early as possible. That's my answer. Why did you want to become an engineer? I did talk about that, so I'm going to skip it. How long do you usually spend on a project, and what problems are you trying to solve now? Again, I kind of talked about it, but in short, it depends on the project. It can go from a few weeks to several years. And the problems I'm trying to solve now is getting all the right data from all my fitness trackers from the equipment into my system, so I can monitor it well. How long have you been an engineer? I've answered that as well. 6 years, I think I said. Do you need art skills to be a good engineer? No, but they're definitely useful. I say definitely useful. They are useful. But though you don't have to have an art skills to be a good engineer. What has been the most difficult challenge what you have faced as an engineer? I talked about that, so I'm going to skip, just mindful of time. What made you think about being an engineer when you were young? Again, my curiosity. How long have you been an engineer? 6 years. What is a pressure vessel? So the pressure vessel is that also can be called pressure tank. You've seen it on my picture. It's that big thing which is used for storing the gas. And as I said in my presentation, you can think about it as the air balloon. So you can store gas in the air balloon. You can either transport it or you can store it there and then you take it out later. So, and that's exactly what pressure vessel does. It stays there. You pump the gas in there to be used at a later time. Have you created anything you like? I did like my pressure vessel, so I can say yes. Are there dangerous parts to your job? Every time you go on site, even though we have like a good safety record, but every time you go on site, there is a risk of something going wrong. So yes, but it's very minimal, and it's quite a controlled risk as well. What motivates you? I think I touched on that as well. It's the challenging projects, challenging problems, which you spend quite a bit of time working it out, and once it works, that's just good, and you want to find a new problem, new project, new challenge again. And that kind of answers the next question: what is the best thing about your job? That's the same thing. Once you see your work in the flesh and working, that's a good feeling. How old were you when you first became interested in engineering? Difficult to say. As I said, like I always had this curiosity from the childhood, but then like thinking about thinking seriously about it, going into the getting the degree, I think about 15, 16 years old. Which university did you go to? Where is the best to study? So I did my degree in the University of Sheffield, which is a very good degree for mechanical engineers. That is in, I think it was in the top 3 in the UK when I did my degree. And it's quite a nice location as well, Sheffield, with the parks and Peak District being on the doorstep. But there are good universities in all the parts of England and the UK, so it shouldn't be a problem to find a good university wherever you want. Did you need to do any special training to become an engineer? The university degree was my special training. After that, I just went into work. And then you have like depending on your role, you have your special on the job trainings. Like if you're using a particular tool, or if you're in my first role, I was dealing with the high pressure gases, so I had a separate training about high pressure gases and the damages they can make. How many female engineers do you work with? So I'd say we have in our area, I'd say we have like a 20-80% split. So on our floor, out of 100 engineers, you will have 20 female engineers. But as I said, it's changing, and we're getting more and more female engineers into the company. What time do you start in the morning? We have like a flexible hour, so we have our core hours in the office, which are 9 to 4, and then you can adjust your time. You can start earlier and finish early if you want, or you can start later and finish later. So I typically start at 7:30, 8 in the morning. Do you like being an engineer? I talked about that. What are your hobbies when you're not working? I play basketball. I play in a local team in Surrey, Cobham Cobras. So that's one of the hobbies, and then I have a family, which you can call a hobby as well. Are there any downsides? What do you least enjoy about your job? Some projects are boring, as I said before, so that can be a big downside when you need to complete that boring project which you don't enjoy. But as touching on from a previous question, you every so often have an interesting project which motivates you to go through that boring project, so you can start a new problem and new project. How much will robots affect our future jobs? It's like, for me, it seems very promising for engineering, because you need engineers to make the robots, to program them, to maintain them. But you are moving the manual labor away from the floor, basically replacing it with the robots. So as an engineer, I'm not too worried about it. That's a short answer to this difficult question. So I'm going to skip a few of them now, because we are running short on time, the ones I answered. Do you like being an engineer? I talked about that. Do you enjoy your day-to-day life as an engineer? Yes, it is quite flexible, and as I said, we have our core hours and you can work around it. So it's quite flexible, and you typically have several tasks running in parallel, so you can mix and match what you do, and depending on your day and on your mood, you can take more interesting parts of your job and do them for a day, and then when you are feeling like doing something boring, you can take and do them. So yes, I like my day-to-day job, and it's quite flexible and interesting. I'm gonna skip that. I answered that. Have you ever worked with another engineering company? If so, what did you do? So my first experience, Automotive, was a different company. And yeah, I was working mainly with the power steering for the cars, and now I'm in the industrial gas company, mainly working with the gases. If you could put engineering into one word, what would it be? Challenges. And it would be solutions to the challenges. So you see, I failed. I didn't put it in one word, but yeah, I think it's challenges for me. What is the biggest building you have worked on? Unfortunately, I haven't worked on any buildings. Maybe it's gonna come late in my career, but at the moment, I haven't done any building, like structural engineering. If you could be involved in any project, what would you choose? As I mentioned before, I'd be interested in doing something with the space rockets or submarines. So yeah, I'd pick one of them. Do you ever have to work with dangerous chemicals? I don't have to, but in my previous roles, I came across them. But again, you have a lot of controls and policies around them. So even though they're dangerous chemicals, if you're sensible and you follow the rules, they shouldn't harm you. Can being an engineer be frustrating? I can be at times when you can't solve the problem which you think you've solved, but it still doesn't work. That can be frustrating. Or when you have a great idea, when you think you have a great idea, but you can't really get your colleagues on board with that, and maybe it's not a great idea. That can be frustrating as well when you realize, yeah, it wasn't really a great idea. So yes, it can be. Would you ever work in a different type of engineering? Yeah, yes. Like as I said, like I moved from automotive into the industrial gases, which is more process-oriented engineering. So I've already done that move from automotive to the process engineering. So yeah, I wouldn't mind going back to automotive at some point, maybe. Or as I said, the space rockets is another thing to look at. I've answered this one. I've answered at what stage did I start my career? At what age did I start my career? I answered that. To be an engineer, what subject do you need to take in high school? I'd recommend physics and maths and chemistry if you're interested in chemistry. Where do you come from, and did you do any engineering at school? I come from Latvia with the Russian background, and no, I didn't. I did maths and physics at school, and then after school, I went straight to the Sheffield University to do the mechanical engineering.
Yeah, I know it's a particularly interesting question.
Yeah, go on.
It said, why is engineering so important? So, and I think we should use this to wrap it up, because I think we've gone well over now.
Oh yes, it is 10 past 12. Yeah, so what is engineering so important? That's a difficult one, isn't it? But basically, engineers design the things we use, and depending on the design, that there are like several things, and the important ones is the usability, how easy they are to use, and how helpful they are to the users, i.e., people and you and me. and then second, what impact it has on the environment, because using different designs, different techniques, you can have a cleaner product which doesn't impact the environment as bad with like CO2 pollution, for example, and the CO2 footprint. So solving these problems of getting the right solutions to the people without harming the environment is quite important in my view, and this is where engineers actually can help and solve these problems. So that's why engineering is important.
Wonderful. Thank you. Right, thank you very much, everybody. I think we're going to have to call it a day there. It's almost it's 12:10. So thank you all very much. And as I said, if anyone has any feedback, please let me know. And yeah, thank you very much. And
no problem. Hopefully you enjoyed that. Thanks a lot.
Yeah, it's wonderful. Cheers, mate. So we're gonna close it down now. And thank you very much, everyone, for taking part.
Thank you. Bye.
Bye-bye.